A very good evening, ma'am. I am Mohammed Hanif from CSCB section, and the question for my presentation is from partial differentiations. So, the outline of the presentation consists of knowing and understanding the question. First, we'll understand the question, what is given, and we'll then go to the data of the question and working of the problem, followed by conclusion. So, here is the question. If u is equals to xy plus yz plus zx and v is equals to x square plus y square plus z square and w equals to x plus y plus z. So find dou of u v w with respect to dou of x y z and also show that w square minus v minus 2u equals to 0. They have given three equations of u and v and finally w, and they have asked us to find out this dou of uvw with respect to dou of xyz, and they're also asking to prove that equation equals to 0, that is w square minus v minus 2u equals to 0. So the given data is the three equations, and let us mark these three equations as 1, 2, 3 equations respectively. So moving on to the working of the problem, here we have dou uvw with respect to dou xyz is dou u by dou x, dou u by dou y, dou u by dou z. Next, dou v with respect to dou xyz, dou v by dou x, dou v by dou y, dou v by dou z, and then dou w by dou x, dou w by dou y, dou w by dou z. Further on, we have to solve the expansion of dou u by w with respect to dou xyz in this form. Dou u by dou x is dou by dou x of u. In the question they have given u value is xy plus yz plus zx. So dou by dou x of u is here x, dou by dou x in the sense dou x, it is partial differentiation with respect to x, and remaining all other variables are considered as constants. So the answer is y plus z for dou u by dou x and dou u by dou y, dou by dou y of u equation. So dou by dou y in the sense with respect to y. So here we have the answer x plus z, and then dou u by dou z is solved in a similar way, that is partial differentiation with respect to z in a sense other than z, remaining variables are all considered as the constants. So here the answer is y plus x, and then in the same way we solve dou v by dou x also. Now we consider the v equation, dou by dou x, that is partial differentiation with respect to x of the v equation. So here we get x square differentiation is 2x, and next dou v by dou y, dou by dou y with respect to y, that is of equation, second equation, that is v. So here we get 2y, in the same way 2z, and now dou w by dou z, dou by dou z, sorry, dou w by dou x, dou by dou x with respect to x for the equation of w, the equation is given as x plus y plus z. So here with respect to x means we only have to do the derivation for the x variables, and we have to consider remaining all variables as the constants. So considering all these constants, we get 0, and then partial differentiation with respect to x is 1. So final answer is 1. In the same way, dou w by dou y, dou w by dou z are also solved, and we get 1 for same dou w by dou y, dou w by dou z. And now we substitute all these values in the expansion of dou of uvw with respect to dou of xyz. Then we get y plus z. So we have solved and we have got this value, that is y plus z, x plus z, x plus y. And then in the second row 2x, 2y, 2z. In the third row 1, 1, 1. So now we have the 2x, 2y, 2z. We have what is common to be taken from this second row is we'll take two common out of them. So here we get 2 of that of y plus z, z plus x, x plus y, x, y, z, 1, 1, 1. And next, on doing row operations, we do the row operations in order to simplify the problem, in order to get the desired answers. So here we r1 is equals to r1 plus r2. First row is to be added with the second row. So now we get 2 into of that of x plus y plus z, x plus y plus z, x plus y plus z. Now x, y, z, 1, 1, 1. And so in the next step, we would take x plus y plus z as common. In the previous equation, we could see that x plus y plus z is common in the first row in all the columns. So we take out x plus y plus z as common, and now we get 2 into x plus y plus z, det of 1, 1, 1, x, y, z, 1, 1, 1. And here R1 and R3 are identical. That is, both are same. We could see here. And so its value is 0. This is according to a property of matrices of determinant. So then we get the entire value of det of that matrix is 0, and we get 2 into x plus y plus z into 0. Anything into 0 is equals to 0. And finally, dou of u v w with respect to dou of x y z is 0. So we can say if the value of dou u v w with respect to dou x y z is equals to 0, then we can say that u v w are functionally dependent. And next, finally, they have asked us to prove the equation. So for that, we take x plus y plus z whole square. What is x plus y plus z whole square? It is x square plus y square plus z square plus 2xy plus 2yz plus 2zx. And here we take 2 as common, and hence we write it as 2 into xy plus yz plus zx. And x plus y plus z, according to the question, that is w. So w whole square, that is w square, equals to x square plus y square plus z square is equals to v. That is also given, and it's present in second equation. And then 2 into xy plus yz plus zx. This value is also given in the question, that is u. So here we have w square equals to v plus 2u. And finally, if we transpose these to LHS, then we get w square plus v becomes minus v on transposing, and then plus 2u becomes minus 2u on transposing. So this entire value is equals to 0. So it is hence proved. So that was all about the problem. Thank you for your patience listening.